So we're talking about expected payoff. So this would be like, I don't know. It does have a lot of ties to like gambling odds and stuff, but it could be like an investment too. Well, I'll just give a really easy example. Let's say you make a $2 bet that, say you have one die that you're going to roll, and you make a $2 bet that you would get a 5 or 6, roll above a 4. And if you win, let's say you get $1. Okay, is that going to be a fair game? Is that going to benefit you? That's kind of what we're figuring out here. So, what are the chances of rolling a 5 or a 6? Yeah, 2 out of 6, or 1 in 3. So that means you should win overall about 1 in 3 times. The way chance works is like you could win 4 in a row. You could roll like 4, 5, or 6s in a row, but if you rolled 1,000 times in a row, the number should get closer and closer to 1/3, basically over time. The chances that it won't just get more and more astronomically hard. So anyway, so you can expect in one game that you'll win about 1/3 of the two. Well, actually, you're gonna get 1/3 of $1 because I said the payoff was $1. So per game, you could expect to win 33 cents. Well, that's not quite right. Because you'd get I think I said it wrong. Well, I should have said like $3 because you got to at least win the money back. So we'll say $3. There we go. Yeah, you got to win more than what you bet. So if you won $3 on your bet, then you can expect to win $1 per game. But it costs $2 per game, so yeah, it's not a fair game. You're going to be losing money. So on number 1, expected payoff. So basically that table means 10% of the time you're going to get 9, 30% of the time you'll get 7, and 60% of the time you'll get -5. So if I went back to my game, I should have put like 2/3 of the time you'll get $0 dollars back. So yeah, still adds up to 1. That doesn't really make a difference. So what's the expected payoff like overall? Like what should you get normally? It's kind of like average. The difference though, on average you count like everything as equal chances, like equal value. So on this one, some things have a higher probability. Anyway, 10% of the time you should get 9, and 30% of the time you should get a 7. This would make more sense if we had a word problem, but 60% of the time you'll get a -5. So in general, I kind of want to say what's the average you're going to get, and I guess that would be a fair word to say, because if you did add the results a bunch of times and divide, this should give you the average. Anyway, if you add them all together, you get 0. So that's how you do those. And 40% of the time, that's number 1. Number 3, just plug it in. 40% of the time, you're gonna get a 60. 50% of the time, you're gonna get a 52. 10% of the time, you're gonna get a 50. Well, before I even do this, you might be able to kind of guess what we're going to get. So, most of the time you're going to get like a 52 or a 6, like 50% of the time you get a 52, 40% of the time you get a 60. So those are like 90% of the time you're going to get one of these two. And then 10% of the time you'll get a 50. So it's probably pretty close to 55, right? It's kind of between these two, pulling harder, and yeah, the answer is actually exactly 55. Okay, number 5, decide if the game is fair. If not, state who has the advantage. Okay, a die is rolled. If the number that shows is odd, player A wins $1 from player B. If it is a 6, A wins $2 from B. Otherwise, B wins $3. Okay. So we are kind of just, instead of like adding up to figure out like in general how much should we expect to get, we're like comparing the two, who's going to get more. That's how this is going to go. So A is going to win in a lot of situations. All the odds gets him $1. So he'll get $1 what percentage of the time? What's the odds that you roll an odd on a die? 3 and 6.5, right? So 50% of the time, A is going to get $1. But if he gets a 6, if the die is a 6, he gets $2. So that's 1 in 6 of the time he's going to get $2. Okay, then kind of pause over there, and then over here is going to be player B. Player B is going to get more money, but he's only going to get money basically from a 1 and from a 2 and a 4, because that's the only rules that player A doesn't get paid. So what's the odds you're going to roll a 2 or a 4? Yeah, 2 and 6 or 1 and 3. So 1/3 of the time, player B is going to get $3. Now, who can expect to get paid more? That's kind of the, or if it's a tie. If it's a tie, it's called a fair game by their definition. I don't think this one is a tie though. That'd be like 1/2 plus 1/3. 2 6 plus 3 is like, comes out like 5 6, and this comes out as 1. So actually, because player B gets paid more per roll, he's actually can expect to get more money than player A. So we're supposed to put not fair, and the advantage goes to player B. Yeah, we can go to 12. These aren't going to take too long. Number 7. 2 dice are rolled. If the sum is 6, 7, or 8, player A wins $5 from player B. Okay, yeah, it's pretty hard to figure out what the odds of rolling a 6, 7, or 8 are. I mean, you could do it. It would take a while. But I think what they mean for us to do is use that table. I don't know if you remember from, let's see, if I can figure out what page it was on. Page 601. So on that table on page 601, it's kind of a long time. It's been over a week ago, but how many different ways can you roll a 6? You can roll a 5 and a 1, a 4 and a 2, a 3 and a 3, a 2 and a 4, a 1 and a 5. So there's 5 different rolls out of the 36. For a 7, that one's kind of easy for me to remember because it doesn't matter what the first die is, the first die roll is. The second die can just, like if you roll a 6, then the second die has to be a 1, so that's a 1 in 6 chance. Or if you roll a 1, the second die has to be a 6, that's a 1 in 6 chance. Anyway, there's a 1 in 6 chance of rolling a 7. It's the best odds. And then an 8, because an 8 is kind of like a 6. You can look at the table, but there's 5 in 36 chance of rolling an 8. Maybe I'll just put this back to 6 and 36. Anyways, if you add all these together, there's a 16 in 36 chance of getting a 6, 7, or 8. Maybe I should have read the rest of the problem. And player A gets $5 if this happens. So this times 5 would give you players A's expected value, expected payoff. Player B, B wins if anything else besides the 6, 7, or 8 happens. 6, 7, or 8 is the most likely rolls. 7 is the most likely, and 6 and 8 are the second most likely. But that's still, if it's 16 out of 36 to roll those, then that's 20 out of 36 to roll anything else. They add up to 36. And player B is going to get $4. This one looks pretty close, and actually it is the same. They both come out to 80 and 36. Well, that would be like $2 in some sense. That doesn't really matter. But they are equal. So this is, you could say, a fair game. Number 9. Suppose you play a game in which you make a bet and then draw a card from a well-shuffled deck that includes 52 cards as well as 2 jokers. Okay, 2 jokers this time, so 54. If you draw a joker, you keep your bet and you get $5. If you draw a face card, you keep your bet and win $2. And if you draw any other card, you lose your bet. What is your expected gain or loss in this game if your bet is $1? Okay, so let's start with jokers. What's the odds you would draw a joker? Okay, 2 and 54. And normally there's 52 cards, but they threw the 2 jokers in, so now there's 54 cards. And if you get the Joker, you're gonna get $5. Okay, I'm not throwing the bet in there because, yeah, you're not really you're not gaining the bet, you're just not losing it. So we don't really need that yet. We'll need it later. And then what was the other thing? If you draw a face card. Do you guys remember what's the odds of drawing a face card? Well, normally it was like 3 and 13. But since we got jokers in the deck, that's going to kind of screw it up. There's 3 face cards per suit, but there's 4 suits. So now there's 12 out of 54 face cards. And if you get a face card, you get $2, right? Yeah. But if you draw any other card, you're basically going to lose $1. So minus, now what's the odds you're not going to draw one of these cards? So there's 14 and 54 chance that you're going to draw these cards. So that leaves a 40 and 54 chance that you're going to draw something else. And it's gonna, I could have written it like this, like plus a negative $1 or something, but you need a minus over here on this one. This is where you're losing money. Okay, what do you guys think? Is this a winning game or a losing game? Well, why don't you all try and plug that in the calculator, we'll find out. It's kind of close, so it's maybe hard to guess. What did we get? Okay, so we're talking about money. What would that mean in money? You're losing an average of what? 11 cents. So they just put an 11-cent loss, I guess, instead of negative 11 cents. You don't usually use the cent symbol. That game wouldn't be too hard to beat. I mean, it's not a good bet, but still. 11 cents is not a huge loss. Okay, number 11, test taking. On a multiple choice test, a student is given 5 possible answers for each question. 5 possible answers. The student receives 1 point for correct answer and loses a quarter of a point for an incorrect answer. If the student has no idea of the correct answer for a particular question and merely guesses, what's the student's expected gain or loss? So it's like they're trying to discourage guessing, basically, or not give you an advantage for guessing well. But does this kind of take care of it, basically? So if you have no idea what the answer is, what's the odds you're going to get the right answer? odds you get the wrong answer. 4 and 5. And what are you gonna lose? A fourth of a point. So this is like 1/5 and negative 1/5, right? So it's gonna come out as 0. So there is no advantage to complete guesses. If they wanted to make you stop guessing entirely, they could have changed this to like 1 and 3 or something. Then there'd be a disadvantage to guessing. But as it is, it's just a neutral. They might, I feel like they might do this on the SAT, but I'm not sure. Do they? Do you lose points for getting the wrong answer? I feel like they do. Okay, I guess I'm done then.